Okay, we're going to do 2.7 transformations, so make sure you have your note packet out concerning transformations. Also probably want your graphing calculator handy. We'll take a look at a few transformations using our graphing calculator. This first one, they just want you to graph these three lines, y equals 3x plus 4, y equals 3x minus 1, y equals 3x plus 2. I think the key thing here is the fact that this one's going to have a y-intercept of 4, which would be 1, 2, 3, 4, and then we apply the slope up 3, right 1, maybe down 3, left 1, connect the dots the best we can. Next one, I don't think it's a stretch to say we're going to have a y-intercept of negative 1, apply the slope 1, 2, 3 over 1, 2, 3 over, and we should recognize these as parallel lines. So one could say that if you were to compare these two to y equals 3x, you could say this guy is y equals 3x except up 4. This guy is y equals 3x except down 1. This guy then, based on what we know, is probably y equals 3x but up 2. And I could go up to 2 and I could graph the line up 3, right 1. And I could get, boom, there you go. Not new material. So what we're going to be looking at today is some of these other guys here. Graph all of these things on the same plane. So y equals x squared is a parabola. So we can go y equals. I should probably get rid of my stuff here. So we can go back to y equals, and we can go to x squared, and we can zoom, standard. We can go to number 6, and we can see our graph. And we have y equals x squared. It's a parabola. And then we could go to y equals x squared. I think it was plus 1. And when we graph that, we see y equals x squared, and we see y equals x squared plus 1. Went up 1. Coincidence? I think not. And now we can go to y equals x squared minus 1. And when we graph that, it should be no surprise that it's the same thing, except we go down 1. So when we're talking about what did you notice, we should be saying we have the original graph, y equals x squared, g of x is down 1, and h of x is up 1. So we're going to be able to make a conjecture here that when we add or subtract to the outside, this guy right here, what we're adding or subtracting is going to affect that parent function. Parent function is what's in charge, so that's going to control whether or not it goes up or down. Here we go. Vertical transformations of f of x equals x squared. We have plus k if k is greater than 0, we're going to go up k units. If k is less than 0 or negative, so we're subtracting, then we're going to go down k units. And we saw a bunch of examples with that earlier. And now we could make a conjecture that says y equals x squared minus 8 I believe that the g of x function is going to go ahead, and this is going to make it go down 8 units. This guy right here is going to make it go up 10 units. And uh-oh, they tried to trick you. Put the 5 out front. That's the same as x squared plus 5. And we could go up 5 units. We could graph those on our graphing calculator and make sure that that is the case. Feel free to do that on your own. Next, we're going to graph these guys. We got y equals x squared. We're going to do y equals quantity x minus 2 squared, x plus 1 squared, x plus 4 squared. So when we look at our graphing calculator, we go back to our y equals. And the first one we were going to do, we can go down to this guy right here. And we can say, we're going to do x squared, and then we're going to do x, whoops, we're going to do x, parentheses, x, parentheses, x, I think it was plus 2. Is it plus 2? Minus 2. Now when we look at this, here comes my y equals x squared. Now here comes my y equals x minus 2 squared. And this may be a little bit of a surprise to some of you, where one might have assumed that y equals x squared, x minus 2 squared would have gone 2 to the left, but in fact it went 2 to the right. So the next one they want us to do, x plus 1 squared. Let's try that one. Y equals x plus 1 squared. Notice this is in parentheses now. So this is the difference between adding or subtracting to the entire function compared to adding or subtracting to just the value before we square it. And that went 1 to the left, which leads me to believe if we go out here and we go down to, I'm going to go down to the green one, and we do x plus 4 squared, we'll be able to look at the graph. And based on the fact that this one went 2 to the right, this one went 1 to the left, I believe that this is going to go 4 units to the left. So what's different about the plus and minus right here? Vertical translation, whatever's added or subtracted makes it go up and down. Now my horizontal translations, there's x squared, minus 2 is 2 to the right, plus 1 is 1 to the left, and plus 4 is 4 to the left. So it's kind of the opposite idea. If you think about it in terms of what it would mean to be x-intercept, what would make this 0? The value of negative 4 would make that one 0. And that's what we're looking for here. So it's the opposite idea. It says the graph of g of x equals x minus h squared is the graph, but we translate horizontally. So when we translate horizontally, notice if it's positive, so the minus is part of the solution. So we're going to go right. So this would be an example would be y equals x minus 4 squared. That's 4 to the right because the minus is part of the solution. It's kind of the opposite idea. And now if it's negative, what does the negative do inside the parentheses? X minus negative 5 squared actually ends up looking like x plus 5 squared, and that's going to go to the left. So if we take a look at a couple more examples here, I believe the top one, x plus 2 squared, if I was making a prediction, I would say this is going to go left 2. This is going to go left, we'll get her, 2. This is going to go right, 4 because of the minus 4. The value of h is 4. This is going to go right 3. So when we take a look, if we graph those, that's what the plus 2 is going to do. It's going to go to the left 2, right 4, and then right 3. Okay, so we're going to put both of these together now. We're going to put both of them together. So when we say inside parentheses is going to be left and right, so you can see it over here. Inside the parentheses is here. This is going to be left or right. Outside the parentheses, up or down. So you got to watch out for that opposite idea. I would suggest this one is probably left 1, up 1, and then we have right 2, up 6, and then we have left 2, down 3. So when we watch these things now, that first one, here's g of x, and watch the vertex of the parabola, the bottom part. Left 1, up 1, and then you got the red one here. Here's the red one. So this guy is over there, and that went right 2, up 6, and then the last one went left 2, down 2. Let me clear this out so we can see left 2, down 2, and we end up right down there. So inside parentheses, left and right, kind of an opposite idea. Outside parentheses, up and down. Dilations. If we were going to graph these on a same coordinate plane. So f of x is black. It's on the graph. F of x. It's our regular f of x equals x squared. And then we multiply by 2. Notice, it goes up faster. If you multiply something by 2, it's going to go up a little bit quicker. Now we're going to multiply by 1/4, and it goes up much slower. It's going up at 1/4 of the speed. It's going to slow down. That's the red one. And then we have negative 2x squared. What do you think the negative is going to do? It's going to flip it over. It makes all of our values negative. So this is going to be basically the reflection. The g of x, the blue one, and the k of x, the purple one, are reflections of one another. And then the other one, negative x squared, flips it over. So we could make a conjecture that says if our value in front of the x squared, like 2, is going to be greater than 1, it's going to make it go up quicker. It's a bigger number being multiplied. Less than 1, fraction, between 0 and 1, makes it go up slower, and the negatives are going to flip it over. And if we take a look at the value of a, if a is greater than 1, it's going to have a vertical stretch. It's going to go faster. If the absolute value of a is less than 1, it's going to be the absolute value now. It's going to compress it vertically. It's going to be wider. Wider is fine. If they ask you, skinnier and wider is fine. If a is negative, it's reflected upside down. Okay, so if we were going to do everything at once and we wanted to make some descriptions. So if we start with this guy and we wanted to say we're going to compare these things to f of x equals x squared. This is going to be vertical stretched or thinner, and this will be down 9. Okay, so it'll be skinnier and down 9. H of x, it's going to be reflected or flipped. That's the negative, and then it'll be thinner because it's going to be going faster, and this will be up 1. Next one, this guy will be wider because it's going to go slower because of the 1/5, and this makes it go down 7. Next, order of operations. The very first thing we would do, this is going to make it go inside the parentheses, right 1. This is going to make it go flipped because of the negative, flipped. This is going to make it be thinner as well because of the 2. Going to go up faster, or down faster as this case maybe. And this will make it go down 2. Last one. Remember the opposite idea. This means left 2. This means skinnier, thinner, or faster. Thinner is fine. And this is up 1. You can check those things by putting those into your calculator and checking to see whether or not that's what happens. Okay, we're going to stop right there, and you can get working on your 2.7 homework.